Hey guys, today we're going to look at similarity and congruency of two-dimensional figures. As you can see here, we're going to start with similarity. Just to apologize, I'm actually using my finger here, so I can't actually write properly. So I'm not going to write things out, you'll have to listen. So earlier in this unit, we looked at dilations, and when we made dilations, we actually created similar figures because we could see that they were proportional. So a scale factor of 2 just doubled everything and the proportions remain. So with similar figures, the corresponding sides of the two similar figures are proportional, and the corresponding angles of the two similar figures are congruent. Now notice these two similar figures here. If you look at the corresponding angles, they are congruent. Okay, and then also if we look at the proportions of the sides, the corresponding sides, we have 5 to 10, so a scale factor of 2. And then if we go from these two, and then these corresponding ones are doubled. Likewise, for example, if we look at 5 to 1, this is the largest to the smallest side. We look at the largest to smallest side. That's an equivalent ratio, so they are proportional. Any two similar figures will be that way. And we could look at some shortcuts for triangles. So with triangles, here's an example of a pair of triangles that we only see that there are two pairs of congruent angles. But because we know that if there's two pairs of congruent angles, okay, the third pair must also be congruent. So if we only have two angles, pairs of angles that are congruent, that's enough because we know by the triangle sum rule, therefore the third angle must also be the same. So these two triangles ABC is similar to DEF because of the angle-angle similarity postulate. So we'll be using those postulates throughout this exercise. And let's just look at a couple examples here. So in the first example, we can see they look to be equivalent, okay, but we need to have three pairs, and we don't have two even now, but we need to check this here first. So what is this angle? Let's look at this angle here. So this is 105, so that means this has to be 75, okay? And right now we can see that, well, we don't have two pairs of angles that are congruent. That's 72. So these are not similar. They're not proportional. Over here, well, how do we know if these are similar or not? We've got a big triangle here around the outside, okay? And then we've got this little triangle here. And then we know these lines are parallel. So, well, right away we know that this angle is shared here, okay? And then if I just change my color here, this angle and this angle, those ones, they must be equivalent because these are parallel lines here. And so by angle postulate, we know that those are similar. Another example here, if we just put this angle here, we know these are vertical angles here. And so now we have angle, and we can see that those are similar. So we didn't have all three angles. Also, if we know that all three corresponding sides are proportional, then they are similar. So if we're given two figures, we can check to see, and these are triangles, we can check to see that all three of the corresponding sides are proportional. So in this case here, we can look at, well, 9 to 6, okay, that's what we're using. 9 to 6, that's 3 halves. And then we could look at 12 to 8, and here's a 12 to 8 here. That's also 3 halves. And then 15 to 10, that's also 3 halves. Okay, we can also use this ratio here, these two here, and then go to the next two, and then go to the last two. And we can compare them that way as well, as I showed before. So let's look at these two triangles here. Okay, so if we look at 14 to 21, these two here, okay, that would be 2/3. Then we can look at these here. That's also 2/3. These are half. That's a half. This one here is 4/3, and this is also 4/3. So we can see that those are proportional. Moving on to another postulate, which is, side angle side similarity. So if we have a pair of angles that we see are congruent, and then we're going to look and see if the pairs of corresponding sides are proportional. So here's an example here where we have 4/3 and 8/6. Those are proportional. So if we come down and check here, we've got our pair of angles. And so if we look at 77 to 42, that simplifies to 11/6. And then 110 to 60, and again, that also simplifies to 11/6. So that angle inside and then those two pairs of corresponding sides are proportional. We know that these are similar. Here, it's pretty simple. Here we have our angles. So we could look at it this way. 10 to 10, is that equal to 70 to 70? Or is 10 to 70 equal to 10 to 70? And we can see that they are proportional. Okay, so those are similar figures, and you can refer back to these notes for the postulates once we get going here. Now let's look at congruent figures. Congruent figures are actually a little bit more simple. They're just identical. So when we looked at translations, rotations, reflections, those were all transformations that produced congruent figures. So if two objects are considered to be congruent, this is the notation that we use for that. So triangle ABC is congruent with triangle DEF. And that means that the corresponding sides of congruent figures are congruent. And also the corresponding angles are congruent. Okay? So they're just identical figures. It's important that we make sure that we get the corresponding parts. Now, when we look at triangles, again, there are some shortcuts for triangles. We don't need to have all of that information to determine if they are congruent. Here's an example where we have side, side, side congruency. So if there are three identical sides that correspond to another triangle, those are congruent. In other words, if you took three sticks of different lengths, and then you produce those same three sticks and gave it to another person, they would always form the same triangle. And that's one of the reasons why triangles are such a strong shape, and they're used in all kinds of structural designs for their strength. So let's look at a couple examples here that show side, side, side. You know, we're only given two sides, but since this side is shared, it's a common side. Obviously, we have side, side, side congruency. Again, here we are sharing a side, so we have side, side, side congruency. Another shortcut method that we can see if two triangles are congruent is if we have a side and an included angle and another side. So we have the two sides are congruent and the angles are congruent. Okay, so obviously these lengths are the same, and as this angle increases, this side increases here. So if we keep that angle the same, the third side is going to remain the same. Let's look at a couple examples that show side angle side congruency. Here we're only given two sides, but then we can see that these are vertical angles. So these are congruent figures. Here we're given the two sides, an angle, and then there's an included side here. So side angle side congruency, these are congruent objects. And again, don't go by what the diagram looks like. You can't get out your ruler and measure it. You need to really go by the theorems here. So you know if these objects are congruent, we have to be able to prove that they are with one of the postulates. Here's angle side angle. So an angle and an included side and an angle. Now this kind of makes sense because as we close these angles, they form the vertex here. So if we have the same length side over here and these two angles are at the same, they will close off at the same point over here. So they will form congruent triangles. So an angle, included side, and another angle. Okay. So here's an example of that. We've got two angles and a side. Now, we're missing this angle. However, if we have angle side, we technically have the third angle. So we know this angle is congruent with this angle because of the similarity proofs that we learned about with angle. So we know that these two angles here that I'm pointing at are also congruent. Okay. Let's look at the next one. So here, obviously, we have angle, side, and then these are vertical angles, angle, side, angle. So that one's a pretty simple one to look at. That basically does it for the descriptions, and you can go back and look at this video. And what I'm going to ask you to do now is the first part, you're going to write your answers in the document. So just type them in here. So you're looking at these two shapes here, and you're going to decide, are these two triangles, are they similar or not? Okay, so the first one we're dealing with if they're similar or not. Okay, so we say yes or no. If they are, then you need to state by what postulate. How do you know that they're similar? Okay, and that includes for all three of the four of these. And as we move through them, we get to determining if these triangles are congruent. Okay, and we're going to talk about, okay, if they are, by what postulates. So is this triangle congruent? Are these two triangles congruent? If so, yes or no. So if yes, by what postulate are they? Okay. And then we get through to this part. Now we're going to get to the written portion. And as you get to the written portion, this is a very short section. This is the part that you're going to take a picture of and submit it on the assignment for today. Okay, so either it's given to you that they are congruent, or you have to determine, oh yeah, these two triangles are congruent because of this, and then you're going to have to determine, well, what are the corresponding parts to help me make an equation so that I can solve for the variables. Likewise, here's with the congruent figures. Okay, this one here is the trickiest one, but just go back to deciding, okay, well, what triangles might be congruent here? How do I know? And then start filling in the information that you know based on that. All right.